of x equals the square root of 2x minus 4. Okay, so those are the two functions we're looking for the domain for. So let me grab you guys popsicle sticks, and we will go ahead and get through this. Isai, are you there?
Yeah.
You can pick either 1 or 2. Which one would you prefer to do?
2.
Okay, so for number 2, we have the square root of 2x minus 4. And if you're really confused about what this might look like, we could go to Desmos. We could plot it. Hey, look, I have Desmos up right here. So we have g of x equals the square root of 2x minus 4. So let's move this so we can see it. So where does our domain start for this, Isai?
2.
Yeah, so it starts at 2, okay? So are we gonna have a round bracket or a square bracket at 2?
A round.
So round means it's not included, but is there a point here at 2?
Yeah, I think.
Yeah. So we're gonna use a square actually, okay? And you can even see if I sub 2 into this function, I get 2 times 2, which is 4. 4 minus 4 is 0, and the square root of 0 is just 0. So 2 is a valid point. We can put that in there. And then how far to the right does this function go?
It's infinite.
Yeah, so it goes to infinity. And now what bracket do we use?
The round, right?
Yes, perfect. Thank you, Isai. So our domain for h of x is 2 to infinity. All right, what questions do you guys have on number 2? Okay, if there are no questions, then I'll draw somebody for number 1. Delamar, are you there?
Yes.
All right, so Delamar, for number 1, we're looking at the domain for this absolute value function. Would you like me to graph it on Desmos for you?
Yes.
Okay, so let's graph it on Desmos together. Let me pull this up. There it is. Okay, so this one is going to be h of x is equal to 3. And then we need to pull up our absolute value function, and then x plus 4. And it needs to be plus, not equals. There we go. All right, so that's our function. Let's move this screen so that we can actually see. I'm going to move my thing over. So this is our absolute value function that we've graphed right here. That green the green function is g of x. Okay, so how far left can this function go?
I don't know.
Does it look like it ever stops moving left?
No.
So what should it approach?
Infinity.
Negative infinity, right? Because we're moving left. And what type of bracket do we use with the infinities?
A round.
Yes, a round. Very good. Okay, and then to the right, does it look like it ever stops moving to the right?
No.
No. So what should my upper limit be?
Infinity.
Yep, and round bracket for that as well. And we are done. Okay, so we have found the domain for both of our functions. What questions do you guys have before we move on to notes for today? Okay, if there are no questions, I'm going to go ahead and start notes. So let me make this bigger. Okay, so let me get a fresh page for notes for you guys. Okay. All right, so you need to write these down. These are important. And I believe, let me double check. I should have them up from when I taught this in my semester-long class. So you should be able to follow along with a handwritten copy if you need.
Shut up, Chino. You can always You can own a fucking Toys Carco with fucking.
Whoa, hey, let's watch the language. What's your question? Who is that? Okay. Okay, so yeah, the solutions should be here, okay? So you can always pull them up if you need. They'll open up in a PDF that you can pull up on your computer. Okay, so we're gonna start with it. So we've talked about absolute value functions a lot. 2 classes ago, we did absolute value equations, and then we did absolute value inequalities on Tuesday, and today we are talking about applications of absolute value. Okay, and this is honors 2B. Okay, so there are 2 important things we need to know when we talk about applications of absolute value. There are 2 important things to know. Okay, the first thing that we need to know is the average of the values we are looking at. So this is the number of things that we expect to happen. So the average of the values we are observing. Okay, and this average is what we expect to happen. Okay, other questions on that? Does this concept make sense of using the average? Okay, the second thing is how much we are willing to be wrong. Okay, so this is like what we want to be, the first important thing. The second thing is how much we're willing to be wrong, how much we're willing to vary. I'm going to write that as well. How much we are willing to vary. Okay, what questions do you guys have about those 2 important things? Now, those may not be, they may not immediately make sense to you in terms of absolute value. We're about to go through what that is, so don't worry if that part doesn't quite click yet. I'm pretty sure I said we were recording. Yeah, we are. I just wanted to make sure. Okay. So the format that we use these 2 key features in is in our absolute value function. So we're going to have an absolute value function, and it's going to be x minus a number equals another number. Okay, so the pound sign or the hashtag sign is going to represent a number, and D is going to represent another number. This number right here is going to be the average that we are talking about. Okay, this is like the ideal number. Okay, and D is going to be the distance away from the average. or how much we vary. And this is also a number. Just a different number than the one over here. Okay, so what questions do you guys have? You may wonder, okay, what if I have like a really big list of things? How am I going to calculate the average of that? For simplicity, we are going to calculate the average by taking the min and adding it to the max and dividing it by 2. The D value, which represented how much we can vary, is going to be calculated by taking the max and subtracting the average from it. Oops, you guys can't see. I'm sorry. Or you could take the average and subtract the min. Okay, both of those are options. Okay, so what questions do you guys have before we move on? Okay, so if you're following along, at this point, I'm switching to a sheet that has kind of some applications problems on it. Okay, it looks like this. The top of it does. It's supposed to be like kind of like a little foldable. This is the first page. It says 1.4 notes at the top. We are gonna skip the very first page because we did it in our warm-up. We looked at the domain of absolute value. So we're gonna skip this first page, but it is written in our solutions. So you should be able to go back through and you can fill this in if you want to. But for time's sake, when I did this with my semester-long class, it just took too long, and this front part is something you guys should know from previous classes and should know from lessons that we did at the beginning of this semester. So we're going to skip this front page, and the page we're going to start on looks like this. It says applications of absolute value. So I'm going to staple my little booklet together so it doesn't keep falling apart. While you guys keep copying that, and then we will go ahead and switch to this. So you can pull it up on your computer and follow along with the questions and just write it down on notebook paper if you want. You don't have to have this printed out. And you also, as long as you know where to go back to look at these questions, I don't care that you actually sit down and write out all of those, all the words in these questions, okay? And just so that you're able to see them. Okay, so we're gonna go ahead and start here. Sorry for my sloppy little book, but there it is. Okay. So we have reiterated up here the 2 things that we need to know, the average and then how much we're willing to be wrong, okay? And we're going to try to solve each of these problems using that information and the format that we looked at in our notes. And I'll write that at the top here, x minus r. I'm going to name our average. The mathematical symbol for average is putting a line over the x value. Okay, and then we're going to call this D since that's what we called it in our notes. So this is x minus our mean or our average equals D. Okay, and this was our average. D was how much we're willing